An atom is the smallest piece of matter that still maintains the physical properties of that chemical element. And in chemistry, we use light to study atoms. Now, white light, we can pass white light through a diffraction grating. So I have a diffraction grating right here that we'll be using. And when white light passes through a diffraction grating, we get something called a continuous spectrum. It's called a continuous spectrum because all of those wavelengths of visible light are present. We see them all flowing one right into the other. So we'll see red light, orange light, yellow, green, blue, indigo, violet. And it's a continuous spectrum because there are no breaks or separations between those wavelengths. So we're going to go ahead and look at an example of white light right now. So I'm going to light this candle, and this candle is going to be our source of white light. And as soon as that match is struck, you see all these rainbows, and it's that white light going through that diffraction grating, and you see this red, orange, yellow, green, blue, indigo, violet. You see, and that's that continuous spectrum. All of those colors flow one right into the other.
What?
Now, atoms also give off light, but unlike white light, atoms give off a different kind of light. And we can also pass atomic light through a diffraction grating, but we won't get a continuous spectrum. You only get a continuous spectrum with white light. Atoms instead are going to give us something called emission spectrum or line spectrum. And we call them line spectra because we're going to see specific wavelengths of light. And those specific wavelengths of light are related to the electrons that an atom has. And so what we're going to do is we're going to compare the continuous spectrum that we just saw to the line spectra that we see from an atom. So I'll show you one example of an atom right now. And what I have right here, it's a carousel, it's a spectrum tube carousel. And inside of each of these little tubes, it has some just some atoms of a specific kind of gas. So what I do is I turn it on and I start passing some electricity through this tube. And if you use the prism glasses and you can look at this atomic light, you won't see a continuous spectrum. You'll see an atomic spectrum, or you'll see an emission spectrum or a line spectrum.
Today we're going to look at some resources that we've come up with for 8th grade physical science. We're going to cover the periodic table. We'll cover atoms, the subatomic particles that make up the atoms, trends on the periodic table, things like atomic size, atomic number, atomic mass, radioactivity, and then we'll also use these things to balance some chemical equations. And we're going to tie all of this then together in a series of digital lockboxes that you'll be able to complete with your students virtually. You'll have that option to do virtually. So I'm going to start by sharing my screen. And all the resources that I'll present here, these will all be shared with all of the teachers that are participating in the 8th grade physical science sessions. And so this very first one is it's going to be our notes presentation. And this is certainly something that could be shared with the students. In fact, I would probably share with my students because I've included some practice slides that we'll look at where you'll see we'll have some kind of interactive things where kids will get to practice different concepts that we'll cover. And then, teachers, though, I'll also provide a key for these notes as well. So that way you'll have the answers there as well. And you'll also have links to all the other things kind of all included with that key for the notes. All right, so we've got our periodic table, lockbox notes. This is where I would begin if I was teaching this in the classroom. We're looking at an atom, right? We have the definition of an atom. It's the smallest piece of matter. It still maintains the physical properties of a chemical element. It goes through the different subatomic particles. We have our proton, neutron, electron. And then we're going to include just a short video here about analyzing atoms using light. And so this is then going to give us a little information about the electrons that make up atoms. And from there, we will start talking about the periodic table. And this slide just talks about how the periodic table gives us a way to organize elements. Each element name is represented on the periodic table by one or two letters called a symbol. And we have a whole bunch of information. We have the name, the symbol, atomic mass, and atomic number for each element in its own box, all there on the periodic table. And we know elements are arranged according to their atomic number, and that the atomic number is equal to the number of protons that it contains in its nucleus. And an element in its neutral state, so when it doesn't have an electrical charge, it's just in its neutral or ground state, will have the same number of both protons and electrons. And then the difference between an atom's atomic mass and its atomic number is then equal to the atom's number of neutrons. So then we show a couple of just simple equations at the bottom. You could add up protons and neutrons to make atomic mass, or you could subtract protons from atomic mass to determine neutrons. So this is kind of our very first practice slide. And what I've done is I typed this up as a slide, and then I set this as the background. So if you do share this with your students, they're not going to be able to change these different questions that are listed. And then what I did is I went and I created these tiles that kids are going to be able to cut and drag. And you're going to notice I made several of them. I cut out a picture, and I just copied and pasted, and I just kept copying and pasting to make several of these tiles that they'd be able to use. So this first task we want students to do, we want them to practice with atomic numbers and atomic mass. And we're asking students to determine the number of protons, neutrons, and electrons in each element that's listed below. And it says that it's listed in this notation. It might be new for students. They may not have seen this before, but it's going to be the element's name, and then with that element's atomic mass. And so this first one is an example. So we see beryllium-13, and that tells us that it's the element beryllium and that its mass number is 13. So what we need to do is we need to determine how many protons and neutrons and electrons are there for beryllium. And so the first thing I would tell my students is we need to go to the periodic table. And so then I included a link to the periodic table here that students would then get to go. And this is going to forward you to a Jamboard, a Google Jamboard. And Google Jamboard's a pretty neat tool. You're able to do several things with that. If I just pull up the next slide here, this is where your students will be directed. And on the side, you're going to see a couple of tools. There's a pen, and it gives you a couple different ways that you can use that pen with different colors. And then erase that. I'm on select right now so I can see the mouse. You can add sticky notes. I added the credit for this periodic table here as a sticky note. You can also add images to this. And I really like this laser function. If I click that, and that's kind of what I'll be using here, you can show just a really brief, and it trails and then it disappears. And I think that's a really neat function as well. So I'm pretty excited about that. But we wanted to know for beryllium-13, so a beryllium atom with a mass 13, how many protons, neutrons, and electrons would that element have? So here's beryllium right here. And we see that beryllium is number 4 on the periodic table. And so atomic number 4 means it would have 4 protons. So then if I flip back to the slide for protons, I know that I'm assuming right now that it's an electrically neutral element. So if it has 4 protons, it will have 4 electrons. And so to determine the number of neutrons, you would subtract the mass number minus the protons. And so 13, we know that here, minus 4, which we found from the atomic number on the periodic table, gives me 9 neutrons. So then students have a couple of other elements they're going to practice with. So we see carbon-14. So the first thing we need to know is what's carbon's atomic number. So if we flip back to the Jamboard, and I'm still on my laser pointer, and here's carbon, carbon-6, so it has 6 protons. So I'm going to take this tile and I'm going to drag it. It has 6 protons. And right now I know if it has 6 protons, it's also going to have 6 electrons. And so to find the number of neutrons, I'm going to subtract 14 minus 6, and I know that's going to give me 8. I can drag my 8. And then I see another one, phosphorus 36. So again, I check the Jamboard. There's my phosphorus. I got 15 for my atomic number there. So I know that it has 15 protons, 15 electrons. Nope, I only have a 21 left, but I also know 36 minus 15 is going to give me 21. And I feel like 8th graders ought to be able to do that, that kind of subtraction fairly easily. All right, so then we move on to isotopes. And we know that all atoms of the same element always contain the same number of protons. So like a hydrogen atom is atomic number 1, and so it's always going to contain 1 proton. But atoms of the same element can have different numbers of neutrons. So this means the atoms of the same element can have different atomic mass numbers. And atoms of the same element with different numbers of neutrons are called isotopes. And so each atom of every element has its own mass number. Every atom has its own mass number. That what scientists do is they take that average mass value of all the isotopes in the whole world of each element, and they record that average mass number on the periodic table. And that can get confusing for students sometimes because they'll see the mass number and they'll think, well, that's for all the atoms of whatever element they're looking at. And it's important to remind them that that's actually an average of all the isotopes, and that just like we saw on the previous slide here, carbon-14, this carbon atom that we're speaking about here has a mass of 14, even though the mass number that you'll see on the periodic table might not be exactly 14. So we're going to do the same thing. We're going to do that same kind of practice, but this time what you'll notice is they're all nitrogens. They're all nitrogens, but they all have different masses. So the nice thing here is we go back to our periodic table and we find nitrogen, and its atomic number is 7. Well, they're all going to have 7 protons here. So we'd use our tiles and we would fill in all 7 protons. They're all going to have 7 electrons. So what they'll notice here then is that your number of neutrons that's the only thing that's changing. So for a nitrogen 14, it'll have 7 neutrons. But for a nitrogen 15, imagine we'll have a 7 and a 7, and then we would need the 8 for that number of neutrons. And then for 16, we would need a 9 for that number of neutrons. And I included a couple of extra tiles. And you can certainly edit this however you'd like, if you'd like to change any of these out, but hopefully this just gets you started. Okay, so then we move on to patterns on the periodic table. And the first thing we're going to talk about is properties. And so that we have 7 rows, and these rows are called periods on the periodic table. And so we know there's 7 rows. Now that some students get a little confused because they'll see the F block rows down below. And that's there because if we didn't pull that F block out and we didn't put those bottom 2 rows down, it looks like there should be 9 rows. Those bottom 2 rows actually belong in the 6th and the 7th row of the periodic table. But if we did that, I always tell my students it would be funny because then your periodic table, it wouldn't fit on the textbook page. You'd have to have this huge, enormous, long periodic table, and most of it would, well, not most of it, but a good portion of it would be the F block, and it would be really long, and it just wouldn't fit very nicely. I always say somebody thought to just take the F block out and put it down below, and now it all fits on a sheet of paper. That always kind of makes them laugh. But really those 2 bottom rows belong in the 6th and the 7th row of the periodic table. And then we have 18 columns. And those columns are known as groups or families on the periodic table. So elements that are located in each column share a lot of similar properties. And because you can get to the end of the row and then you start back over, we see these properties repeating over and over every time we go down another row. And so that's that periodicity. That's why it's called the periodic table, because those properties keep occurring periodically. So 4 groups or families from the periodic table I would want to make sure that my 8th grade students were starting to become familiar with. And that would be, depending on the version of the periodic table you're looking at, you would either see a group 1 or it might show up as group 1A. And those are the alkali metals. And then we also have the alkaline earth metals, the halogens, and the noble gases. And so again, I've included, now this time we have a different Jamboard for a different periodic table. Let's see if I can get to, hiding me here. That's not what I wanted to do. Okay. Sorry, I clicked the wrong button. Okay, so if I go to this one, I'll just show you what it looks like, because my sharing screen is blocking my Jamboard that I need. So here it just shows you, would you like to make a copy of it? And that way the student has their own Jamboard that they can mark up and add their notes to if they'd like. But what I like about adding this one in is this one's color-coded. So it's different from the black and white Jamboard. And down here, you're going to notice that the different colors go with those groups that I just talked about. The alkali metals, oh, they're right here. And then the alkaline earth metals, right? And so they're right here. They're in that second column. And you see this one, we see 2A. And then I just count across. So I would say this would be the third column, fourth, fifth, sixth. And then you get over here and you notice it starts up number 3 again. It's going to bother some of the students, but you just tell them not to worry about it. You just keep counting. So all together, all the way across, there's 18. Then we look at the halogens, and they're going to be kind of right in here. And then the noble gases, and they're this column here. The other thing that's important to point out to students is that hydrogen's kind of over here, but you'll notice it's a different color. Hydrogen is not an alkali metal. Hydrogen is a nonmetal, so it shares similar properties. It's very, very small, but it is not one of the alkali metals, and that's a good point to bring up. Okay. So keeping with periodic trends, or patterns, we see the elements. Again, we already talked about how they're arranged by their atomic number. As we go from left to right across the rows and then down the periodic table, the element's atomic number continues to increase by 1. As more protons are added to the nucleus, the mass of that atom increases. So we see atomic mass increases as we move from left to right and as we move down. So here I have some practice. I want the students to think about these 5 elements. All right, if we look at these 5 elements, can we put them in order of increasing atomic number? And so if I go back to my periodic table, this is the one I want. All right, and then I'll show you a different feature here. So I know I've got aluminum and xenon, lithium, calcium, and nitrogen. So now I'm going to turn on my marker. And there's a marker. No, I want to do marker. And I'll do green. Okay, so I know that lithium is one of them. So my lithium here. And then I forgot, okay, I got aluminum, xenon, aluminum. Here's my xenon. And where's the other one? Nitrogen. And calcium. There's nitrogen. And there is my calcium. So if I'm looking at these and I say, okay, well, lithium is going to be the smallest out of all of these. So lithium is going to go first. I'm just going to click on it. I'm going to drag it over. And again, I've set this question as the background, so the students aren't going to be able to change it. They can only drag those tiles over it. So then my second largest is going to be, if I keep going, it's going to be nitrogen. And then they can continue adding the tiles there to increase those. All right. And then we do the same thing with atomic mass. We can go back to our periodic table. And this time, if you want, you could either erase them, you could choose a different color so it doesn't get confusing, and they can kind of flip back and forth with those and arrange them. And then the next pattern we talk about is atomic radius. And this is a little bit of a different concept than atomic mass or atomic number, because now we're talking about the atom as a sphere. And the size of the radius of the atom is related to the electrons orbiting around the nucleus. And so each element gains 1 proton as it goes from left to right across the periodic table. But each element also gains 1 electron as it goes from left to right across the periodic table. And those electrons, as they continue adding to each of those elements, they fill that outer shell of the atom. They just keep adding and adding and adding. And the more electrons that you get, the more those electrons kind of pull closer and closer to the nucleus. So in the very first column, you just got 1 wild electron just circling, and it's kind of everywhere. And then you get another electron, and then another electron. And by the time you get to the noble gases, that outer shell is completely filled, because now we're at the end of the row, and that atom's radius, then it kind of shrinks, and it becomes the smallest in that period. So when we're ranking the atomic radius, as far as increasing size, atomic radius is going to increase the opposite direction. And so that's what we have here. We have it increasing as we go from right to left this time, but then still down the periodic table. So then we have, just a new set of 5 elements then that we'd have them ranking this time, increasing atomic radius. And again, I'll include the answers to these just so you can check yourself. That'll all be in the key for the notes that we're providing here. And then we talk about the pattern of radioactivity, and that one's fairly straightforward. Pretty much everything that occurs after lead is radioactive. And radioactivity, I always like explaining that as well. It's just when the nucleus of an atom has too many neutrons and not enough protons. Because what happens, neutrons by themselves are unstable. So when protons are close enough to the neutrons, they prevent those neutrons from breaking down. But when you get an overabundance of neutrons, which happens after atomic number 82, there's not enough protons to keep all those neutrons in check. So we have the kids, again, they can practice. This time we're doing a little bit different. We're doing sort of a sort. So which of these are going to be radioactive and which of them are not going to be radioactive, and they can click and drag these as well. The other thing I wanted to be sure to point out, because radioactive elements are unstable, it's common to see their average atomic masses in parentheses. And so again, some of these things I'm pointing out, those will come up when the students get to the lockbox challenges that we'll be talking about here shortly. Okay, and then the very last thing we'll go over is balancing chemical equations. And the trick to balancing chemical equations is just to make sure that the number of atoms for each element is equal on both sides of the reaction, on both sides of that arrow. And so I just wanted to go through one example here, and then the next slide will have another example with these same tiles, these different types of tiles that students will be able to click and drag. And so the first thing I like to do with my students is I like to tell them, you know what, just divide the reactants, which are the left-hand side of the arrow, from the products, which are the right-hand side. So we're going to put this kind of dividing line. I always like to use a dotted line. Okay, and then what I want to do is I just want to go ahead and show how many atoms do I have right now on both sides. So I know right now on this side I've got a chlorine and I've got a silver, and then I also have an aluminum. And then on this side, I have a silver, and I have an aluminum, but I have 3 chlorines over here. So the problem is the chlorines, and that's where we're going to start. We have 3 over here, and we need to make 3 over here. And the only way that you can increase the number of chlorines is to put a coefficient out in front. And then I tell my students that when we add a coefficient out in front of that term, that then we use that distributive property. So then we're going to multiply by both of them. So I know right now I need 3 chlorines. I only have 1. So I know 1 times 3 would give me 3. So I come over here and I find my tile that's a 3. I'm just going to put it right here. So now I have 3 chlorines. So I already had 1. So now I'm going to put 2 more. But now I have 3 silvers as well. And the kids will kind of groan a little bit, and that's okay. So now I just add 2 more silvers. So now I need to go back to the right-hand side, to my product side, and make sure that my number of silvers is equal. So I know now I have 2 more silvers I need to add. So I'm going to 2 here. 2 more here. All right, and then I think we're good, because now we have our 3 chlorines and our 3 chlorines, our 3 silvers and our 3 silvers, 1 aluminum and 1 aluminum. You can leave it like this, but sometimes if students are new to balancing equations, they don't like to see those blank spaces there, so I included some 1s, and you can just tell them it's an understood 1, kind of like in algebra. A lot of your students probably either in pre-algebra right now or and so we have our coefficients there as well.
The AG.
Yes. Oh,
Right hand side.
thank you. You caught me. I said something wrong. Okay, here we go. Yeah, sorry, I was just going out. There we go. 3 AGs. What was I thinking? Yeah. So thank you. Yeah, and your students will catch you too. I get going and I just don't think about it. So there we go. Now we're good. Now we have our 3 AGs and our 3 AGs, and our 3 CLs and our 3 CLs, and 1 aluminum and 1 aluminum. Now we should be good. And so again, I'll have two more practice ones on the next slide then that students will be able to practice with. And so that's it. That's all of the content that we're going to cover is this. And what we're going to then be able to use is all the information from these notes will then feed into this series of 5 challenges that we've turned into a digital lockbox experience for students. And so I'm going to show you then the this is our master copy of this digital lockbox. And I will be completing the 4th and the 5th lockboxes today. But I have I have like 3.5 of them completed right now currently. And so what I've done is I have links, and these are all going to force you to make copies for all of them. And so that way it'll show up in your own Google Drive. You'll have the notes for the periodic table lockbox slides that we just went over. But then you're also going to have a student instruction sheet. And that's going to walk students through just basic information they'll need to complete each of the digital challenges. And then you're going to notice you'll have your own link. So that way, if you want to edit any of these lockbox activities, you have the start that I started, and you can format it to however, make whatever changes you'd like for your students. I even thought eventually I'd like to use the same format, but then change the values so that I could assign a lockbox to each, to a group of students, and then they wouldn't all be getting the same answers. That's just going to take a lot of time. But that's something that you could do is just create the same idea, but then just different values in there that get assigned. But then I also include a link that will take you to the students. So we certainly don't want to give students the collaborator link because then they can get on and change. But we do want to give them the link so that they can go on and complete each challenge. Now, when we go to the very first challenge, if I go ahead and open that, they're going to be able to just begin this challenge. And what this is going to do is, at the very beginning of our notes, we talked about how we use light as a tool to investigate atoms, and how electrons, and it talks a little bit about that at the introduction, that the atoms, when they receive energy, are going to give off they're going to emit their own kind of light, and that it's an emission spectrum, which is different from a continuous spectrum that you would get from white light. And so students are going to use some pictures and then compare those to some knowns in the student instructions for that. And so then they're going to enter their symbols. They'll actually be entering in the symbol, and if they type in the correct symbol, it'll direct them to the next question. And then when they complete this first challenge, they'll get a code. But you can see right now, to enter this first challenge, all they need to do is enter their email address. And this is so that if you wanted to set up a spreadsheet to collect your student responses, that way you know which students are submitting which. And again, you can format this yourself. If you would also like to collect their name at this, you just get on and add a box to include their name as well. So it's whatever you're welcome to make any additions to this. Okay. So they're going to complete challenge 1, they'll get this code, and then we have the code right here in the master for you because I know we've made a lot of these digital lockboxes. Actually, we've made a lot of lockbox projects in general, and it's just always nice to have all of the codes in one place just for your own knowledge. So that way, when you're fielding dozens of questions, you kind of know, you always have a place to go back to, and they're going to then use that code, and it reminds them within their the student instructions. They need to keep track of what that code is because they'll use this code to enter then challenge 2. In challenge 2, what they're going to do is they're going to do some of that practice with isotopes. So they'll see the element with the mass number, and they will be calculating the number of neutrons. Now, what I really like about challenge 2 is that up here. That's the right code. Okay, so I see hydrogen 3, all right? And I know that hydrogen, and if I get confused, I could go to my periodic table, but I know hydrogen has an atomic number 1. And so if I 3 minus 1, that would be 2. So I know that hydrogen would have 2 neutrons. And they're going to need to answer 8 of these correctly if they don't miss any. But what's going to happen is, let's say they miss one. So aluminum 28. Well, I know that aluminum has an atomic number of 13. So 28 minus 13 is 15. But let's say I do my math wrong and I say, oh, 28 minus 13 is 13, and I try it. What I've done for this is I've set up Oh, let's try another one. So I've set up remediation tiles in each of these. So depending on the answers that they choose, if they would get it wrong, it's just going to scoot them backwards and have them try a couple more until they can then move on. And once they've correctly answered 8 of the different isotopes, or 8 of the different elements correctly, so now I know, okay, aluminum 30 minus 13, I know, okay, 17. Okay, now I move on to gold, and then I continue on and on. Once I finish that, then I'm going to get my code to move on to challenge 3. I did build in that remediation there for students if they're just needing a little extra practice. I'm trying to get back to my master. All right, and then our code that we get for challenge 2 is then going to take us to challenge 3. Challenge 3 is with patterns, and challenge 3 is sort of like a scavenger hunt on the periodic table, and it's going to have them answering it directionally. So up, down, left, or right. And again, the student instructions are going to clearly tell them, you know, which letters to type in. So I think you type in a capital U if you want to travel up, capital D if you want to travel down, and so on. And again, they're going to use their periodic table Jamboard if they want, and they can use this all through these challenges, and then mark these and make notes to themselves just to help them keep track. So they can have several of these tabs open as they're working on it. They'll finish the patterns, they'll move on to balancing, and it will be just very similar to then the balancing practice that we finished our notes with. So they'll be, you know, balancing using coefficients, and that will just be a series of questions on, you know, figuring out which coefficients would balance the equations. And then we'll get the code from 4, and then we will enter that in for our alien periodic table. And with the alien periodic table, that's going to be a really fun one, where they're going to this alien planet, and they're trying to figure out their language barrier, and they're going to have these 26 mystery elements, and they're going to have clues, and the clues are going to have them basically be able to determine what these 26 mystery elements are, because they all correspond with our periodic table of elements. And so if we look at back to my drive, I just want to show you, I've also included a blank periodic table that they can use in connection with the colorful periodic table and the black and white periodic table, and they can make their own notes here as well and kind of keep track of them. And then they'll be entering into that 5th challenge the correct identity for the 26 mystery elements. And then that will be it. And then what you have them do with that 5th code is up to you. You could have them submitted if you use Google Classroom, but hopefully these links should work no matter what learning management system that you have. I think that does it. I don't know, Stephen, do you have any questions? Did I miss anything?
No, I think it's pretty cool. I'm excited for when that last one's there together. I know when we're recording this, it's not quite done. But I think that's going to be pretty cool. But this is I think a really good way for students to develop an understanding.
Yeah, definitely going to give them a lot of the practice that they need to get comfortable with the atom, the periodic table, the trends, subatomic particles, and then balancing equations. So, and again, you're free to use these materials however you want. Make edits, make them your own. Hopefully, it's just gives you a good start for when you get to this topic. Let us know if you have any other questions. Let us know what we can do to help you.
There you go. The only thing I'd mention is the email you typed in was not a real email.
Oh, okay.
So don't send an email to the email that she typed in, because it's probably someone's email.
Oh.
There's probably someone who does have that email, so don't do that.